Welcome, everybody. We're going to get ready to start the next presentation here. Kate Heddleston is going to be presenting about automating your web infrastructure with Chef. Let's give her a warm welcome.
Hi everyone. So like he said, I'm going to talk to you today about Chef and why you should automate your web infrastructure. Hi, my name is Kate Heddleston. This is my information, but if you write down one thing today, just write down my name. I'm uniquely identifiable on the web, and you can find out more than I ever wanted you to know about me if you just Google search me. And this is a link to a Django Chef repo that I made for this talk. So it's a Chef starter kit for creating a Django Python web server. You're welcome to open that up and follow along and fork it and do whatever you want. So here's what I'm going to talk to you about today. So first off, if you're not completely sold on automation, I'm going to talk to you about why you should automate your web infrastructure in the first place. Second, what is Chef specifically? And third, how to use Chef to set up your own personal Python and Django application. So to address the elephant in the room, why am I talking about a tool that uses Ruby programs at a Python conference? Mainly, there are a few big hitters in the infrastructure automation world, and none of them is written in Python. So Ruby seemed like the next best thing. So first off, why you should automate your web infrastructure. This is a short list. It's 4 of many, many reasons why you should automate your web infrastructure. But first off, it's nice to have all of your configuration in one place, and that one place should not be somebody's head. Second, you can spin up a perfectly configured server immediately, and immediate things are always better than non-immediate things. You can change things in one place and have it propagate throughout your entire system. And finally, you can create exact replicas of your production and dev environments for testing and development. So meet Robert. Robert is the guy at my last company who got us on Chef. And at one point, I believe the entire configuration was in his head, but he started porting things over to Chef. And then, tragically, Robert died. I'm totally kidding. He went on vacation. Robert went on vacation for a week, and during that 1 week of vacation that Robert went on, he hadn't been on vacation in like 2 years, Rackspace randomly killed our production master database for no apparent reason, and everyone had to scramble to get up a new database, to back it up, to get it replicating, and fortunately, he'd moved us over to Chef, so creating a new server was easier, and we were stabbing our eyeballs out for less hours than we would have been otherwise, which we all know is a huge win in software programming. And Robert came back, and everyone had taken care of everything, and he got to be on vacation. He also, by the way, has no idea that he's in this presentation. All right, so this is my artistic rendering of a semi-typical production environment. You've got maybe a load balancer, some front-end servers, some back-end servers for asynchronous tasks, a database or database cluster, Sentry, Nagios, Graphite servers, the list goes on and on. And so one of the reasons why you want to centralize and automate your configuration is that as your system grows, you want a central global view of all of the configurations and how your servers interact with each other. So you want to be able to think about your system from this perspective as opposed to this perspective, which is a local view of a single server, where if you're doing command line installations, you're thinking about one server at a time and how they fit together. Whereas if you use a tool like Chef, you're thinking about all of your different types of servers and how they fit together in the system overall. Next, like I said, you can create exact replicas of production and for testing and for development. So if I'm building in development, I never have to wonder, is my code going to perform differently in production because it has a different operating system or because it has some unknown installation or some configurations that are different. You know when a server is an exact replica of another server. You can also update all of your servers of the same type at the same time. And then finally, the use case that I use Chef for, I use it for my personal projects. And my personal projects are pretty small. I'm usually the only one who's taking a look at them. Sometimes my mom, if she wants to see what I'm up to, so my web traffic doubles that day. But I have everything installed on one server. And I use a pretty typical stack: Nginx, Gunicorn, Postgres, Django and Python, Celery, RabbitMQ. And in this case, I could probably go through and install everything manually faster than it would take me to learn Chef. So why bother? Like, why not just go and do this all by hand? Well, As I cited before, sometimes Rackspace likes to randomly kill servers, so I can recreate my awesome web application that I'm building instantly. Additionally, if I want to spin up new projects, that's really easy. If I want to spin up a bigger server, because maybe my grandma's looking at it, and so my web traffic has tripled, I can do that as well. And then finally, if I want to change my stack, I can go in and I can edit. I can add SQL Alchemy or Flask to the installation list so that I have those on my servers, and I can change things around a lot faster than if I configured it by hand and then forgot what I'd put on that server and then went back and tried to replicate it on other servers. So in other words, I no longer have to think about managing my servers, which is great for me because I actually like building features. So what is Chef besides a really bad kitchen metaphor? According to Ops Code, Chef is reality-based automation for the cloud, and to this day I have no idea what that means. So I went and asked some other people for better explanations of what Chef is. Chef, these are the two descriptions that I like the most. So infrastructure as code. Rather than thinking of configurations and library installations as command line or going and editing files on a server, it's code, it's programs. And in this case, it's Ruby programs, so don't hate on it too much for that. Additionally, it's a global view of your system as opposed to a local one. So Chef allows you to configure things globally, essentially. So you can have your servers interact with each other in the code files, and you can separate your web servers from your database servers. Terminology. This is the super fun part of the talk where I just give you a bunch of terminology and definitions. This is not a complete list of terminology because we'd be here all day. So these are just the things I think you need to know for the upcoming section. Your Chef server. Your Chef server, in addition to being the most adorable server in my presentation, is also the central storage for all of your configurations. And it stores your configurations as structured data in JSON. It uses a bunch of different stuff on there. You can do really robust things with your Chef server, like querying. It uses CouchDB for storage. I use it for really simple stuff, but if you were managing a really big production environment, Chef server is meant to scale with you. Additionally, hosted Chef, Ops Code will host up to 5 servers configuring 5 servers for you, and then you have to pay. But you can host your Chef server yourself, so it can be free for forever. Knife. Knife is the command line tool that allows you to talk from your local workstation to your Chef server. So when I make changes or update code or create new programs, I use Knife to basically sync them to the Chef server. Nodes are just servers in your system, so your load balancer, your front-end server. Roles are a really cool way of abstracting what a node does and what should be installed on it. So, for example, a web server role versus a database role. We can kind of understand from the name what a web server role should have on it and what it should do. It should serve web traffic. It should probably have, in my case, Nginx and Gunicorn, Python and Django, whereas a database role doesn't need a lot of the stuff that a web server role needs. It just needs to deal with the database and the configuration for that database. Additionally, the role has the run list of all of the installations for that particular role. So run list, it's a list of things that are run. It can talk to other machines in your infrastructure by their role. So I can open up the firewall in my database to all of my front-end web servers in that role. So that's how you can use Chef to have a global view of your system. In your actual code, you can use these roles to talk about how you want your servers to interact. And finally, you can query over the roles to grab all of your front-end web servers and do something specific to them or have them do something, I don't know. Cookbooks. Cookbooks are the base unit of configuration. So you'll have a cookbook for Nginx, you'll have a cookbook for Postgres, you'll have a cookbook for Gunicorn, etc. And recipes, this is the only place where the kitchen metaphor comes into play. Recipes are in cookbooks, and recipes are basically the program that gets run when that cookbook is installed. So a recipe is the Ruby program that has the list of installations and the actual code for executing different things. Okay, so if we go back to our production environment, now that we have our Chef server, and we think about how these interact, all of those servers talk to the Chef server for their configurations. So for example, if I want to create a new front-end server, I'll create a box. It will talk to my Chef server to get the list of all of the things that should be installed on that server and all of the configurations. And so when it's done, that new front-end server is an exact replica of the other front-end servers. And I'm not wondering, does it have installations that the other one doesn't? Is it missing anything? Conversely, if I update the front-end web server role on my Chef server, those changes propagate out to all the front-end servers. So I know they're all in the same exact state. They're all consistent. So I'm never wondering how, like, basically, did someone on my team go into a front-end server and install something for testing purposes, which I don't know why they're doing that on production, but they could. This is my awesome artistic rendering of how I interact with my Chef server. So that's a self-portrait of me at my workstation. And your local workstation, in my case, it's my laptop. It can also be a cloud server. I have all of my code in a Git repo, so you can use it the same way you'd use any code in a Git repo. You can have multiple people accessing the same code. You can fork it. You can clone it. So different people can be working on the same Chef repo in the same group. I use Knife to sync things up to the Chef server, because it doesn't matter if I push it to my origin or anything like that. What matters is if I knife it up to my Chef server. If it's not on the Chef server, it's not going to work. You can also get some really awesome Knife plugins, and these are all open source on GitHub. And if you just search Knife Rackspace or Knife EC2, what these plugins will do is they'll let you talk to your hosting provider. So before, I could just configure my server in one command. Now I can actually create a server and have it be configured in one command. So one command is better than two. This is the view of my local workstation. So this is the Chef repo that I have. You can see there's a Cookbooks folder where all the cookbooks are. Data bags are essentially just what they sound like, bags of data. In there's a users folder, and in that users folder is my personal user. It has my public SSH keys, my shadow password, and if you're using the repo that's up on GitHub, you should probably take my user out and add your own in, unless you want me to have access to all of your boxes. And then there's a folder for roles, and there you'd have your web server role, your database role, etc. So when I got started, I forked the empty Chef repo from opscode. It has nothing in it. I cloned it down to my local site, or my local workstation, and then I played a game called See If They Have This Cookbook, where I just typed in Knife Cookbook site download, and then whatever it was that I wanted, so Nginx or Gunicorn. And I was like, this is great, it's magic. I just kept downloading all these cookbooks. And then I typed in Knife Cookbook site download Django, and I get this error message that's like, this cookbook has been deprecated, use application Python. And if you go look at application Python, it's this monstrous cookbook where they're like, we want you to install like 70 billion things. And I was like, I just want Django. I really don't want to install Apache and all of this other stuff. So this is the part where I decided to write my own cookbook. And so this is the recipe in my Django application cookbook. It's a really, really simple cookbook. Cookbooks can span from being incredibly simple, so just Python pip installing Django, to doing a lot of complex configuration, overriding default attributes, whatever you want. So mine is really simple. Mine just installs Django, simple JSON, PyTZ, some other stuff that I really wanted on my server. I could also have this cookbook configure the server. I could have it go in and create a folder, clone down my personal project repo, and start Gunicorn if I wanted, but I was too lazy, so I just didn't write that. When I'm done with my cookbook, I have to sync it up to my Chef server. So Knife Cookbook upload Django application, and it's on my Chef server. And so whenever I go to create a new server or update any of my existing servers, it will get my new cookbook. Additionally, this is what a role looks like. So a role is just JSON. It's really simple. And the core part is that run list that you see there. And at the top of the run list, you can see there's a role base. And the base role is essentially something that I think should be installed across all servers. So it's got Python in there, it has Git, it has build essential, it has my user, because I should be able to access all of the boxes that I create. So roles can essentially inherit from other roles. So you can create tree structures and have them interact this way. And then my web server role also installs Gunicorn, Nginx, Django application, and Postgres. So once I've created my web server role, I have to sync that up to my Chef server. And then, now that we've done all this work, we've gotten all of our cookbooks, we've done our configurations, this is the command that I run to create a new server and configure it. So Knife Rackspace server create, it will use the role web server, it names it chef.myserver.org. All of the other dashes and numbers basically mean that I'm creating a 1 gigabyte Ubuntu 12.04 server. And if you want to use EC2 or Linode, the plugins are essentially the same, it's just Knife EC2 server create. So this is what happens when I run that command. Knife Rackspace will go and talk to my hosting provider to create my server. So once that server is created, it will run Chef Bootstrap. Chef Bootstrap is what installs Chef on that server, and also gives it all of the configuration information to talk to my Chef server with all of the information about how that server should be configured. Chef client is the thing that gets run on each local server to talk to the Chef server and get the configuration. So Chef client is idempotent. You can run it as many times as you want. If you break something, you can go fix it, sync it to your Chef server, rerun Chef client, and continue doing that until it works. You can run Chef client manually, or you can have it run automatically in the background. If you have it run automatically in the background, you should probably think a little bit about how you're doing that, because if you break something in your Chef server accidentally, it will automatically propagate to your entire system. So that can be dangerous. And then yesterday, during one of the talks, I actually went and I ran this exact command. I created this server. And don't get too excited that you can see the passwords and stuff, because I'm going to kill this server right after we're done. But basically, I'll show you the console output of what happens when I run this command and create my server. So it creates my 1 GB server. It goes and runs Chef Bootstrap on there, so you can see how it's installing Chef. And then it runs Chef client. So Chef client, like I said, is what talks to the Chef server to get all of the information about what should be configured. So now it's pulling down, storing updated cookbooks. So it's pulling down all of my cookbooks: Screen, Runit, Sudo, HTOP, Nginx, all of this different stuff. It's pulling it down. And Chef has really great console output. It's nice. You can see exactly what's happening as Chef client runs the whole time. So it goes, it does a bunch of other stuff. More stuff. Eventually, it starts processing and installing these cookbooks. So you can see here it's processing nginx.conf. It's going through, it's Python pip installing Django. It's setting up folders. And then finally, it tells me that my report handlers are complete. And I get this information back. And so I now have a fully configured server. It has everything on it. And it has all of my configurations that I've set up. So I don't know if we can SSH in. Anyways, it doesn't really matter. But I went in, I created a projects folder. I cloned down my repo. I started gUnicorn, and now my server is running. I make really awesome websites. So once you get everything configured and set up, it really is that easy. I don't have to spend a lot of time now thinking about my servers. I don't have to spend a lot of time worrying what would happen if I need to create a new project. And I can, in a talk, run that command and then pay attention to the talk and do nothing else. And when I just have a server, and I'm like, awesome, clone down my project, hello PyCon. So to sum it all up, you really, really, really should use something for server configuration, anything. I know this talk was about Chef, but I just think that people should automate this process. So I've heard great things about other tools in the space. If you want to get started with Chef, setting up your Django Python server, once again, this repo is the exact repo that I just used to create that server. Other tools like Chef. So I use Heroku. Heroku is great. They manage everything for you. You just have a requirements file that lists the installations and the versions. You deploy to Heroku, and they do everything for you. And people that I know who love Heroku have said that it's like having 2 full-time DevOps people on your team, because they do so much work behind the scenes. Puppet I've heard great things about. So Puppet and Chef are kind of like ideologically different, which is good because engineers love to argue about things like that. And so, yeah, there's a bunch of articles online about Puppet versus Chef, but people who use Puppet really like it. It works well. Salt, the Salt people are here apparently. So Salt is a newer tool. I think it was first released a 1.5 years ago. It is written in Python, but it's much newer than Chef and Puppet. And so I haven't heard much about how it works at like for large-scale production environments, whereas Chef and Puppet and Heroku are pretty well vetted. But you should definitely go talk to those guys, and I'm taking a look at the source code right now, so that's exciting. No developers were harmed in the making of this presentation, but thanks to these guys for helping out, Robert, Adam, and John. And Hearsay Social, my last company, was really supportive and helpful. While I was making this talk, I did a bunch of research on Chef and different tools. So if you want to know about, testing environments with Vagrant or more specific topics, this was a very general presentation on Chef and why you should automate your server infrastructure. But there's some really great talks online about more specific topics, Vagrant, Chef Solo, all these different things. If you want to read something about Puppet versus Chef, or if you want to take a look at the list of open source configuration management software, If you think that like Ruby and Python are too far away from the computer, there are some that are in C, so you can get closer to the machine. And then finally, questions. So you can find me in the hallways, or tonight I'll be at the Hearsay Social Beer Bash from 6 to 8. And yeah, you can ask me anything.
All right, so we're going to be taking questions at the microphone here in the center. And so if you have a question, just walk up to the mic. And then while we're waiting for people to walk up there, we have a short announcement. Just wanted to let everyone know again, there's going to be a Pie Ladies auction tonight upstairs in rooms 209 and 210. The auction is going to have things like iPods, there's some stuff signed by Guido, all kinds of stuff there, so everybody should go check it out. It's at 6:30.
Hi, I'm Brandon. My question is about the users that you were listing there. Now, are those users who can access the Chef repo, or are those put on the file system for SSH access?
Those are put on the file system for SSH access.
Okay, so their shadow salt is in there and all that kind of jazz? That needs to be protected?
Yeah, so well, the public SSH keys, all of that stuff, I mean, you should be using protected versions. But yeah, so there shouldn't be anything in there that's private. But those users are globally accessible throughout your cookbook. So what it'll do is it'll go through and it'll create the user home directory for each of those users. I have a cookbook that does that. But
Okay, for system users, it's the same thing. Is there like, options built in to say this is a system user, he doesn't have a home directory? Or is that something that I would need to add in?
Yeah, you can create different types of users. I think my user is a sysadmin, so, but yeah, you can do all of the different things that you could do on the box manually, you can do with Chef in different ways, so.
Cool,
Yeah.
Thank you.
All right, if we don't have any other questions, let's give another round of applause here for Kate.